So in our work, we did the first order adaptive temporal causal network to model anorexia nervosa. And in particular, we focus on the effects of therapy on the precipitating factor that we will introduce later in this presentation. So why did we decide to model anorexia nervosa, and what is it? So anorexia nervosa is an eating disorder occurring worldwide among females and males of all age groups, with the prevalence of adolescents and young adult females, mostly in the Western countries. It is characterized by self-starvation and compensatory behaviors, and it is associated with low rates of recovery and the highest mortality rate of any psychiatric disorder. And so, like, to get more deep into the why, we decided to report some statistics that we found in this research lab about eating disorder. And I think they're very, like, they were a big motivation for us to go into this topic. So it is estimated every year, 1,300 more cases in the young women of the population in Netherlands suffer from anorexia nervosa. And there is a percentage between 5 and 10% of patients that die. And as we mentioned before, it's a psychiatric disease with the highest mortality rate. And also the recovery is not like 100%. So indeed, we have that 45% of the patients usually recover completely, 30% partially, but 25% do not recover like in an acceptable time span, let's say. Indeed, the illness usually lasts an average from 6 to 7 years, ranging from 6 months to 10 years. And so given those backgrounds, it's also found in literature that, like, despite there are like proliferation of computational models of eating disorder, a treatment for anorexia nervosa is limited and has not really improved in the last 50 years due to the incomplete comprehension about the basic mechanism underlying the disorder. Indeed, like the factors that, as we will see later, influence the development of the disorder are multiple, and their interconnections is not that easy to understand without a correct computational model. So then we divided the factors in these 3 groups according to their roles, and then Smriti is going to talk about them more specifically.
Yeah, so the potential prognostic factors which lead to the development of anorexia are divided into biological. This is according to the DSM-5 manual. So it's divided into biological factors, psychological, and sociocultural factors. The biological factors include gastrointestinal peptides, which act on the central nervous system, which then influence eating behaviors, energy levels, and the mood. Interactions between cortisol, cytokine, and leptin can also be accelerators in an eating disorder onset. For psychological factors, a strong motivational factor is an individual's self-esteem. Individuals tend to hinge their self-esteem on the appearance and body weight, which then results in their pursuit of the supposed thin ideal. And sociocultural factors include parents' own dissatisfaction of bodies and dieting behavior, which is then projected on the children, who then go on to develop eating disorders. Other factors include negative comments about weight, body shape, pressure to lose weight, and which have been associated with body dissatisfaction. Furthermore, parental control, hostility, societal norms about the thin ideal, peer influence, specifically among adolescents, accelerate the process of developing the aforementioned disorder. So for the sake of simplicity of the network modeling, we only focus on psychological and sociocultural factors. The precipitating factors are body dissatisfaction, feeling worthless, and anxiety. And therapy is a great way to break the loop of anxiety and body dissatisfaction. What perpetuates from anorexia is a restricted diet, compensatory behavior, weight loss which is affected by a restricted diet, and a reward mechanism, where the individual focuses on sticking to rules. And there is something called the rule satisfaction, which is also interlinked to anxiety. Teresa will explain the next.
Yeah, sure. So like in this slide, we're going to show you like this network, which was made by the study called Diagnosing Vulnerability Factors in Eating Disorder. This was an actual analysis done by this researcher, where we have that each node represents like factors that influence the eating disorder, and the edges represent the correlation between each factor. And we wanted to show you this graph to like let you keep in mind that like an eating disorder is a like intertwinement between like many different factors, but for the sake of simplicity, we could not include them all. So in order to model anorexia nervosa, we took inspiration from models of that in literature. So on the left, you can see like the first model where there is a focus on the cyclic behavior, where the rewarding mechanism has been influenced, and there is like a perpetuating cycle of anorexia nervosa. Whilst on the diagram on the right-hand side, you can see the division into the predisposing, precipitating, and perpetuating factors that we use in our modeling. So in this slide, I'm going to show you like the basic models of the disease. So in this model, we did not include the control state in the therapy that we included in the further steps. So here we can see that we on the left, we can see the predisposing factor that we decide to model, and that they kind of act as a representative for each of the group of factors that Smriti was talking about before. So we have lack of self-acceptance, thin ideal, and perfectionism that are in this scenario represent the predispositive factors. That then entails like the precipitating factors of body satisfaction and feel worthless, that then will like have a strong connection between like the perpetuating factors that as a cycle in the unhealthy reward mechanism that gets influenced by that. To model this, we use the adaptive temporal causal network, and Cynthia is gonna walk you through.
Yes. Yeah, so for the modeling, we've used the network-oriented model approach. It's a mathematical model which uses network theory to represent interactions between different components of a system. Given initial values of the states, which are the nodes of the network characteristics fully define the dynamics of the network. A key feature of this approach is the focus on adaptivity, or the ability of a system to change over time with response to external or internal stimuli. Each network characteristic can be made adaptive by adding a reification state to the network. So these states get a specific network structure to define the adaptive dynamics, and they're usually depicted as a higher level plane, which will later be explained by Teresa. This kind of modeling allows the design of the adaptation principle of Hebbian learning, which is a form of plasticity, which models the plasticity of the brain. So for the combination functions, we have used the advanced logistic function, and the Hebbian learning function is used for modeling the reification states. And we use the usual role matrices which we have all seen in the assignments. So the connectivity role matrix represents the network structure. Aggregation role matrix illustrates how different nodes in the network interact with each other. Speed factor is the rate of change of different nodes over time, and the initial values define the initial states of the network to define the dynamic of the whole network. Teresa will explain the next.
Yes, so according to this assumption on the factors we set to include and like the modeling approach, we model our model, and in particular compared to the model I showed you before, we introduced the control state for the precipitating factors, which are body satisfaction and feel worthless. Indeed, the control states are meant to act for emotion regulation, and where emotion regulation is stands for the fact that like is like a counterfactual of the thought of the mental state of body satisfaction and feeling worthless. And that's why the adaptive learning that we can see on the first reification level is a connect the precipitating factors and their control state in a learning behavior. And that's also why therapy, we connected therapy such that it has incoming errors from the preceding factors themselves, so body satisfaction and feeling worthless, whilst the outgoing errors from therapy influence the control state, as they can enhance the strength of the control state for these precipitating factors. And according to this model, then we run 3 simulations, where the first simulation is like our baseline, where like the cycle doesn't get through. So like anorexia doesn't develop in our model. In order to do so, we didn't set everything to 0, but we set the predisposing factor to a low value, in this case 0.2. And as we can see, according, which is like, we decided not to have a simulation with 0 because it would not have been meaningful, but we decided to put it at 0.2 because predisposing factors such as like thin ideal and perfectionism and lack of self-acceptance are factors that even though people would not develop the disorder, it's like a mental state that are pretty much shared among the like people in the Western population in our society. And as we can see, like in the course over time, we can see that like, but at the same time, there is no activation of the cycle over time, as indeed there is a convergence to 0, as there is no pathological development of these factors. Then our second simulation is concerned the one where actually anorexia develops. So we took the same model as before, but in this case, we set the predisposing factor with initial state equal to 1, and we set them to have like constant value over time. So their speed, so they have like 0 speed. And we can see that this is enough to make, to push the threshold and like, such that the precipitating factors get activated and the perpetuating factors as well. As we can see, the cycle gets through in the simulation, as we can see this cyclic behavior, where the cycle between the precipitating factor and anxiety goes through. And the third simulation is the one where we can see that so where we activated the effect of therapy. So we set the connection between the precipitating factors and their control state and therapy to be different from 0. So in this scenario, we can see that the disease develops over time, but at the same time, the effect of therapy allows it for a convergence towards 0, because and that's such that the patient, the individual, go back to an initial state of health. So in order to verify the model, verification as defined in literature is where like we have, we do it at a time point where the model is in equilibrium, which is where all the states are stationary and thus the derivative is equal to 0. And where we see in the table, the xt is the value of all the states at time t, which in this case we decided to take as the endpoint of the simulation. And the aggregated impact is the estimated value of xt given the state connections. And the deviance is the difference between the value and the estimated impact, which can be thought as a proxy for the accuracy of the model. And as we can see in the simulation 1 and simulation 3, we have a very high accuracy, as the deviance is almost close to 0, given the fact that the model reach a point of equilibrium. While for the second simulation, where anorexia gets developed and the cycle gets on perpetuating, there is no equilibria, as there is some point where the states are stationary, but there is no point in time where all the states are. So that's why we have an accuracy of the model, which is indeed lower. And then we also validated the model with empirical data. And
yes.
About that.
Yeah, so for validation of the model, we have used empirical data from a survey which was survey on anorexia, which was taken in 2019 during COVID. So the effects of therapy are computed on the precipitating factors, which are thin ideal, body dissatisfaction, and restricted dieting. And for our validation, we have used MATLAB's simulated annealing algorithm. So the above states are targeted for the parameter tuning. It is also important to note that we have used only the non-adaptive parameters for the tuning. The lower bounds are set to 0 and the upper bounds are set to 1. The empirical data was divided into 5 kinds of individuals whose anorexia symptoms range from very severe to very mild. So we have used 5 different kinds of individuals. And after running around 7,000 simulations, we have obtained an RMSE of 0.1266. Yeah. So Teresa will conclude.
Yeah, so like as a conclusion, we want to study that like, okay, so we proved our model with verification and validation, and we realized that like our model is able to simulate in the simple scenario development of anorexia nervosa and the situation where this doesn't happen, or the effect of therapy on it. But yeah, as we mentioned already multiple times, anorexia nervosa is caused by interplay of different factors over time, and thus we have to like highlight the fact that like our model was a simplification, but hopefully it might still give some insights of the development of the disease. Yeah, thank you for your attention, and if you have any question.